Okay, so our last topic for the day is the concurrency of medians of a triangle theorem. So if you guys look, you should have two things you can cut out. It's these two parts here that you see on the screen. So go ahead and cut those out, glue them in. You can pause until you get that done. Go ahead and pause. Okay, so if we got that glued in. So if we look at the definition here, or the theorem, let's break it down because there's a lot to this theorem. So let's take it piece by piece. So the medians of a triangle. So let's not go any further. We got to talk about what is a median. So a median, if we look at the picture to the right, all that is a line that cuts a side of the triangle into two congruent parts. So if you look, do you see how AD, this line here that I highlighted in red, cuts that line BC into two equal parts? And the median also is going to start in that opposite vertices, so the opposite angle to that side. So if you look, we got three different medians here. CE is a median, and it cuts side BA into two congruent parts. And then we have, finally, BF that cuts its opposite side, CA, into two equal parts. So if you look, those three medians all meet up at a central point right here. And what that point is called that's called the centroid. But I'm getting ahead of myself, so let's go back to the definition. Right now we got the medians. It's that line that starts at a vertex and cuts its opposite side into two equal parts. So it says the medians of a triangle intersect at a point, so that point here, that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Alright, so that's a lot. But basically what it says is these medians here, they're all going to meet at that center point that we call the centroid. And what happens is each of those medians gets really cut into two parts, but those two parts can be broken up into thirds. So the way it works is if we look at that part of, let's look at AD here, that red line. This is going to be 1/3. And then this upper part from the vertex to that centroid, that's actually going to be broken into two parts. And so those two parts are going to each be 1/3 on their own. So we have 1/3 here, and then we would have, let me change color, that's not a good color. So we'd have 1/3 here, and then we'd have 1/3 here. So if you look, this line's really going to be broken into three parts, or 3/3 of a line. Okay, so what that means is we get these equations. AP is 2/3 of AD, BP is 2/3 of BF, and then finally CP is 2/3 of CE. So basically the way I look at it is from the vertex to the centroid, that's two parts. And from the centroid to that midpoint on the opposite side, that's going to be one part. So I got 2-part and a 1-part. So this point of concurrency that we're talking about, where they all meet, of a triangle is called, and we already got it down here, but let's write it anyway, it's called the centroid. Okay, so what these next three pictures are for is to kind of get the idea of where a centroid can end up in a triangle. So what we're going to do is we're going to kind of estimate where the midpoint of each of these sides would be on these triangles, and we're going to mark it. And then what we're going to do is we're going to draw in those medians. So if you look what I'm doing here, again, I would use a straight edge if I was you. I'm on my computer, so it's really hard to use a straight edge on this. But that's where those centroids are going to meet up on that one. If we do the same thing, just try to estimate where that center is. If you want to use a ruler and actually measure it to find the center, feel free to do that. And we'll get all these points. And if you look, where they're all meeting up here. And then finally the last one, just the middle of each side We want to draw some lines from the vertex to its opposite middle. Let me draw that one again. And there we go. And if you look, all these are kind of meeting right in the middle of the triangle. Because what the centroid does is actually like a balancing point for the triangle. So if you got a triangle, find the centroid, we're holding it, and you held it right on that centroid, right on the tip of your finger, it would balance out. Pretty neat stuff. But what we're going to do with this centroid is we're going to get back to this rule, that 2/3 rule, to try to solve some problems. So take a minute, make sure you got all these notes, make sure you got those lines in. If you need to, pause it. And then let's look at how we can apply this property. All right, so let's go check that out. So you have another piece here that you can cut out for your notes. If you need to pause to get that cutout glued in, please feel free to do that. You can go ahead and pause now. Okay, so welcome back. Let's take a look at these parts and see how can we solve for these missing letters. It says use the relationship with centroids to solve for A, B, and C in the triangle. So if we look at this first one, the property of centroid says that this piece is going to be one part. So I'm solving for B here in the first one. And then this is going to be 2 parts. So if 4.5 is 1 part and B is 2 parts, could I write an equation that says 2 of these is going to equal 1 of those? So I can say 2 4.5s is going to equal 1B. So that means B, if we just simplify this, is going to be 9. So see how we did that? Notice the 1 part is always from the median, or sorry, the midpoint to the centroid. That's the 1 part. And the 2 parts always from the vertex to the centroid. Let's look at another example. Let's look at trying to find out C. Let's see if we can find the value of C. So if we look, our 1 point from the median to the centroid, that's 4. That's 1 part. And then from the centroid to the vertex, our 2 part, that's C. So what we can say is that 2 of these makes 1 of those. So 2 4s makes 1 C. So that means A is equal to C. Okay, so the same thing works every time you do these problems. You just look at the parts you're given and say, how do those 2 parts relate? So if we look again here, we got this final median here, vertex to the centroid, that's 12, and remember that's 2 parts. And then from the midpoint to the centroid, that's A, and remember that's 1 part. So it's going to take 2 A's to make 1 12. So we're going to say 2 times A equals that single 12. So we solve this for A, we're going to have to divide by 2 on both sides. To cancel out that 2, get A by itself. And we get A is equal to 6. And that's it. That's the whole problem. Alright, so why don't you guys take a look at this one here. See if you can use that example to solve for those missing pieces there. Pause the video now and come back to check for the answers. Alright, so there's the answers you should have gotten for that. If you need to pause to check those, make sure you're good. Feel free to do that. If not, let's go ahead and move on. Okay, so let's take a look at 2 more examples. Again, this is another piece that you can cut out and then glue into your notebook so you have those examples in your notes. So go ahead, pause if you need to cut those out. Okay, so hopefully you were able to get those glued into your notebook. Let's take a look at question number 3. So it says find x if RV is equal to x. So let's go ahead and mark that R to V. That's interesting. That's not even a median. Okay, well that's x. And then it says Rx, there to there, is 2x minus 4. Well, that's weird. They didn't give us any parts of the median, they just gave us a side of the triangle. If you guys remember, when we have a median, that point R is going to be the midpoint of the line. So that means that this piece RV should be equal to that piece RX because this point R is the median. So what we can say is that X is equal to 2x minus 4 because those two parts have to be equal. So from here we just need to solve this equation. So why don't we take this 2x and subtract it from this side so that we can get our x's together. If I did it to this side of the equation, I have to do it to the other. Cancels out there. And then we get x minus 2x. Well, that's negative 1x is equal to leftover negative 4 over here. Divide by that negative 1. And we get x is equal to 4. Alright, there we go, x equals 4. Okay, I think that's all it asks for, yep. So let's take a look now at question 4. It says find x, so we're still just finding x, if AH is negative 6 plus 4x. So let's see, A to H, ooh, that's the whole median. So we're going to say that's negative 6 plus 4x is AH. So the whole median is that. And then ZH, oh, this is interesting. Okay, so Z to H, that's that point from the centroid to the midpoint. That is simply X. So let's think about this. We said that a median is broken into 3 parts. And if we're given the whole median, that means this whole median is 3 total parts. And then we're given that piece that is from the centroid to the midpoint. And that piece we know is 1 part. So that means we're going to need 3 ZHs to make 1 AH. Okay, so you can say 3 times ZH, whatever that is going to equal 1 AH. So now we got to do, let's substitute in the equations that we got. So we're going to say 3 times our ZH, which in this case is X, is equal to whatever AH in this case, negative 6 plus 4x. Alright, so let's scroll up here. Let's solve this out now. We got to get x by itself. So first we're going to get our x's together. So why don't we subtract that 4x from that side. And this side, we know if it's 3 times x with parentheses, it's just a regular 3x there. So I can subtract that 4x from the 3x. It's going to give me an answer of negative 1x is equal to, that cancels, got a negative 6 there. Divide by that negative 1 on both sides to cancel out the negative 1. We get x is equal to 6, final answer. Okay, yep, that's what we wanted to solve for. Alright, so that's it. Okay, so what I want you guys to do now is use these 2 problems as an example. Remember, label how many parts each one of them represent. Then you'll know how to set up your equation. So what I want you guys to do is take a look at these problems on your worksheet, 17 and 19. So it's back to the front page now. Take a look at those 2. See if you can find the value of x for each of those. So pause the video now, and then you can come back and check to see if you got them right. Okay, so you should have got your final answers of x equals 3 for the first one, number 17, and x equals 2 for number 19. Feel free to pause and get this work down if you didn't get it, and ask any questions you may have. Remember, you can text me on Remind, or you can ask Coach Pierce as well for help. Coach Pierce will be my recommendation because she's there, but if you need extra help, feel free to message me. Alright guys, so we got one other part to this video. It's just going to be a quick review of the topics that we learned today. So take a look at these review problems, pause the video, and again, I'm just going to go ahead and put these answers up, and you guys can check your work after you come back from your pause. Alright, so here's the answers to those review problems. So with the time you guys have left in class, not sure how much you have left, but with the time you have left, what I would do is look at those even problems on the worksheet, and those answer key to that worksheet will post it on my website in Unit 3. So go ahead and check that out. And then if you don't finish them in class, I would try to finish all those problems over the weekend so that you have them done, you got enough practice in. Alright guys, have a good weekend.